Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
So I've noticed on the program, that the subtitle of the panel is "Can these projects collaborate?" So I have a plan in 3 questions to ask this. So the first one is something about software, because a program or a software is something where the developer tells the user, you don't need to understand this, I'll give you some capability that you can use. And you can leverage my work, basically. And that means that the capabilities it's offering must have a clear specification. Now, the clear specification can go to optimizing a certain mathematical problem to it just learns, which is a bit weak. And I think all the projects are different because they have different backgrounds in that respect. And therefore, I would like to know for each of your projects how you basically specify what the functions are doing and how do you verify it works, because so maybe I should start with Chijen. Wow.
So how much time do I have? Like 1 minute or something?
I don't know. We are already 10 minutes late, so.
Oh, okay. So as we can see from the presentation, the deep linear is the smallest thing, like in the whole list of packages. So the way we position deep linear is like so the core part is those optimization algorithms. Result they are actually from our research results, and after that, then we have a kind of training and prediction interface. So the goal is to hope that those users they somehow they can easily do the training and the testing, but because we don't have time to do any to spend too much time on interface, so we don't expect that. We expect them to prepare data in a reasonably well fashion. So then, because as a research group, we cannot do too much. Yeah. So basically, we position ourselves. We do the research on the algorithm and provide a simple interface, and we have the ability to maintain the code. Okay. Then that's roughly the way we do the software. Yeah.
Okay. So should I understand that basically you have an optimization problem? You tell the user, I'm going to solve this optimization problem.
Well, a little bit like.
Okay.
Like
I go over to John, who was the next, I guess. And I'm going to try to have the same order, if I can.
So I guess my ideal of how you specify a problem is that you don't specify any representation. You just specify sort of the what should be optimized or what should be predicted in a machine learning sense. So there's things like cost-sensitive multi-class classification, contextual bandit learning, structured prediction, where you can specify what you want without referring to the representation. And then, the hope is that we can figure out through research how to make that happen in an automatic and effective fashion. So that is kind of the interface that I strive for towards NVW. I don't think we always succeed. And there's certainly a lot of options that allow you to tweak representation because we don't know how to automate them yet. But that's where I want to go.
So I think, Hal, you have the same advice.
Well, I guess I can say one other thing.
Yeah.
So I guess one difference between the learning to search stuff and core VW is that maybe the targeted user base is slightly different. So, sort of the targeted user base of the learning to search is sort of domain experts in some other domain who want to use machine learning. And I think the nice thing that we have now is a very limited interface that sort of requires 3 functions. And at least in the sort of version that's sitting on my laptop and not pushed to GitHub yet, there's a fairly well-defined, sort of semantics. Like if you give me this is what you should expect out. But I think, the interface is also changing because we don't know the right answer. And so this is going to change over time.
So I think, Kura.
Okay, so I think my job is easy because we mainly focus on deep learning. You get no guarantee of whatsoever. So but of course, I think there are like two parts to the question. One of them is you get some sort of software interface that you know that it is going to be stable. And that, like, I'm going to answer this question in terms of not Torch, but in terms of the neural network package and the optimization package, which basically what it means to, I think, in the context of the question. In terms of the neural network package, it is designed for gradient optimization. And what we do, how to make sure that when we give users something, there's an intensive set of tests, which basically test the Jacobian and the gradients, right? And because when you do neural networks, you always rely on the chain rule, and then we can test each module individually. We can verify that the gradient computations are always correct. So that is one way. And the interface has been fixed for like 10 years or so right now, I guess. So in terms of interface stability, it is there. In terms of the optimization package, which you can apply any type of gradient-based optimization into any kind of neural network. We have, again, a fixed interface for the optimization, which is basically you take a function which returns you the evaluation and the derivatives, and then some parameters specific to that optimization method. And we have a set of small standard optimization tests to verify that each one of these optimization methods are actually doing what they are supposed to do. But beyond that, like Torch is mainly built to enable people create their own algorithms, and so I don't know how to go beyond any of these. So it's basically you can call unit tests at research level. Everything is there.
Can you give the microphone to? Yeah. Thank you.
Actually, one thing I'd like to add, since Nicholas is not here, from the point of view of Facebook, is that Facebook obviously believe a lot in dog fooding. So whenever any of these packages are conceived in any way, they are like internally they are available internally for employees to use as much as possible, and that helps a lot in sort of debugging the correctness, not just at the unit test level, but even solving large-scale problems, for instance, like actually training the model on the data and things like that.
From the TNO point of view, the user specify a mathematical function that TNO compile and optimize. So for the machine learning, it's not on the TNO side. We put much time on the quality of the software because people rely on their compiler. As TNO is a compiler, we want to have a very high level of reliability. We do it with unit test, but we have also daily bullbot, and we also have bullbot on GitHub on each pull request. So before we merge a new pull request, there have been a pretty good test coverage before even we merge all modification. But we went one step further than that. For the gradient, when we implement in TNO a new operation and define its gradient, we have made some function that will automatically test that the gradient do the right computation, like what they do in Torch, and probably other software too. To debug the TNO optimizer itself, we have created a debug mode. Mostly what it do is that it tests all values before and after optimization. It's very slow. We don't run it in the GitHub for each pull request, but we do it in the daily bullbot. So we know if there's an optimization that trigger a bad result or that change the precision of the result, we will find it. Maybe Bart can talk about the Pylon 2 interface.
Yeah, so at least for Pylon 2, as was mentioned in the presentation, it is largely made for researchers, not as much kind of for the layman user. So I think, although it is possible to kind of use the YAML files to start an MLP model and train it with relatively few lines of code, I think if you want to build any sort of serious model in Pylon 2, its strength is more in its adaptability. So I think we do require the user to know a little bit about machine learning and know a little bit about understand the model that they're trying to code. It's not particularly made for just being able to press the train button. So I think that is kind of a slightly different vision than some other packages.
Yeah, so in in Shogun we have all these black box methods that contain machine learning algorithms from different families, and so it's very important for us that we somehow have a unified interface to combine these things. So I think in terms of what you offer to the users, you want to offer something that is really flexible in terms of, I mean, it was there before, in terms of data representation, in terms of optimization algorithm, in terms of evaluation of your methods. I think it's really important that it's kind of flexible to plug these things together, to be able to plug these things together. So that's the first part of the question. And the other one is, how do you make sure things work? So we also do lots of unit testing, and we actually, like, our whole development process is it's test-driven development these days, because we have had lots of bad experiences if you don't do this, and especially if projects grow over a long time, you get lots of problems with this. We also do this Travis stuff on GitHub, and we also have a build bot, because we're offering all these different language bindings on all these different operating systems. So we have like 30 computers constantly building, compiling tests. But one thing I'd like to add is you shouldn't just be doing unit testing, but also if you have a framework that can be used to build pipelines of data, some processing, doing something with it, and so on and so forth, you should actually test the whole pipeline also. And so we call this integration testing. So we have like examples of pipelines that we run, and then we dump the state of all the objects to file and compare to it. So we have, for every patch, we have an exact notion of what states of which object changes, and that turns out to be quite useful.
You want to answer this one, Daniel? Daniel's the one who does all of this for us, because we started with just me, Daniel, and Matt in the office, and at that point it was like we all designed our own little pieces and sort of spun around in our chairs and asked people how it was going. And at some point I think we went where everybody else went. I mean, we started with extensive unit testing, but we took away the keys from everybody to just push merges off to our server. So everything's done through pull request, everything's code reviewed, everything's unit tested extensively, mainly on Windows, because it's the one machine we don't develop on, but then the developers all run the tests on Linux and Macs. And we have a combination of both unit testing and functional integration testing for models where we know the answers. I would strongly recommend, if people are testing gradients, that you use finite differences. We found more and more of that being useful for our complicated gradient calculations, just in terms of tests, but we've got all kinds of crazy testing going on. And the other comment that I think is worth thinking about if people are going to go off and build their own project is, by test-driven development, I think the important part there is writing functionality that couples being easy to document and easy to test. Those two things are very closely related. And what you'll find is people without strong programming backgrounds, and by that I mean people who aren't used to writing public APIs, maybe they're grad students or scientists or something, it's very important to get them into the mindset of actually writing specifications for things that are testable, rather than writing these things that are bristling with controls and have lots of combinatorics. So modularity, I think, is key for testing. I just wish I could convince the rest of my developers, other than Daniel.
Me too on testing. It's very important. I think any significant code base just doesn't work unless you have constant testing.
Yes, sure. But I'm more interested about the specification part. What is the guarantee that you're making to people who are going to use the software?
Well,
which is what is also what you're supposed to test.
Well, the BSD license says there is no guarantee.
I'm not sure. The point I wanted to make is it's following a bit this finite differences. So if you have well-defined interfaces for your objects that you can combine, you can actually do some kind of automatic test generation on them, and that's also what we do in Shogun for all interfaces that are defined. We kind of feed it with, like, take serialization. We have to serialize objects, so we can do this for all objects that ever are written. It's automatically added to a class. Or if we have gradients, we also do this finite difference thing. We have a checker for this, so whenever you have this, it's added automatically to the list. And I guess that's very important, actually, because it's hard to keep discipline up otherwise.
So let me try to summarize what I understood from the point of view of guarantees, and you tell me if I make it wrong. I saw three very different levels. One is just like liblinear, libsvm, and maybe stan, in fact. Is you guarantee the goal. The goal is optimizing a certain problem or computing certain probabilistic values. And the exact algorithm is your freedom, as long as you do it. Like Matt can do all these things in the way he wants, as long as he computes the right quantity. And Chi-Jen can do anything he wants in linear, as long as he finds the optimal, which is testable. There is another group of software, like I put VW there, and also Shogun, where you guarantee that you implement a certain algorithm, pretty much. I don't know if it's true. Let me continue. Let me continue and comment. So there is a certain specific algorithm, and you guarantee that you implement this pretty much the way it was described, or slightly improved in ways that are described clearly. And there is the third level, which is the deep learning code, where you guarantee that you're going to implement a particular model, and you're going to compute the correct gradients that you're supposed to use the right way. Is that a good summary of the situation, or somebody thinks it's wrong?
I think that's not. I mean, you can think about it that way, but I don't think you should think about it that way for what we want to do in VW. So there's kind of there is a particular algorithm right now, but that I'm making no guarantee that algorithm with that flag will have the exact same algorithm in the future. I would try to guarantee that if you have a multi-class data set, you'll try to minimize multi-class loss, right? That's a kind of guarantee which I think you can rely on.
Is this something you can verify?
Yeah, you can verify that.
How?
You get out a bunch of predictions and you compute the models.
Yes, you can verify for a particular problem. You cannot verify that your code does that always.
So one of the things we want to do in the near future actually is get a very large suite of different data sets that we test against.
So what I mean here is that
Well, do you have an example of software that does do that?
Oui, compiler. A compiler promises that it's going to actually maybe it's right. Okay, that's right. A compiler promises that it's going to translate your C code into reasonable assembly code that does the same thing. Yeah.
So VW promises that the complex thing will get translated into the simple thing, such that you optimize the complex thing.
A SQL database promises that it's going to give you the data that satisfies certain criteria. You don't care how it does it. And we haven't reached all this at the same level in machine learning. There are domains that are more mature, like probabilistic modeling, where the framework is more mature, like probabilistic modeling or SVM or optimization-driven things, where it's pretty clear. Domains where it's a little bit less mature, which is what John's trying to do to solve the problem with computational learning reductions. And the domains where it's still very open, like deep networks. Curiously, they still work, they still do things. So let's go to my second question. So my second question is about, if you want to collaborate, you have to share goals. And I can see goals very different in open machine learning tools, from documenting a particular paper, proving one particular point, supporting a research agenda, or taking over the world. So why do you put yourself in that spectrum? So we're going to go in the same order and just Chi-Jen.
Oh, thanks. Okay, so this is a good question. Just to ask, like, why we want to spend time on doing that. Okay, so let me go back to like how I got started to develop libsvm in the year of 2000. So my background wasn't in machine learning. Okay, my PhD was in numerical optimization. But for some reason, after I started teaching, I decided to move to machine learning, and I found out that it's not easy to use machine learning software. So at that time, I looked at quite a few SVM papers, and I found out that, well, why their results are so good, but when I try the software, somehow it's not easy to generate the same results. Turns out that those experts, they did data scaling, but they didn't write that in the paper. They think that's too easy because in their papers they only write advanced algorithms or something. So I thought, well, this is not very good. Because at that time I didn't even know what cross-validation is. And I said, okay, I want to write something that is useful for me, but also for some, at least for other people who are like me. So those are roughly how what we have been doing since then. But we also know our constraints, because then because also from my optimization background, I do libasement and liblinear. Behind that, they are optimization algorithms. So we develop algorithms to solve them and put them in a package and available for users. But as a small group, then we cannot spend time on interface or something. So basically, we just try to see what we can serve, and if every day we get mails from users, and some of them they say, oh, because of this software, then that helps them a lot on their work, and then we feel happy. So that's why we are here.
Okay, let's go to John and Al.
So VW has primarily been kind of a vehicle for research. So there's various research that I and other people have been involved in, and I guess there's a particular taste in that research oriented around things being particularly fast or overcoming big obstacles. So that's what it has been. But my research program is solving machine learning, and so I think it's actually taking over the world.
Yes, I think Kuhai was next.
So I guess for us it's also similar. The main point, for the main three of us, and I think for everyone else, is we want to do research, and then there are certain particularities, the way you think about problems and the way you think about your solutions, and you just don't find something that is suitable for you, and you start writing it. And then I think we also sort of enjoy the fact that if we write these things in a general manner, others also who would like to think about problems and solutions the way we think about those, they would use these same actually software, and it's a cycle. It's going to improve because more people use it, we are going to learn from others. So I think it goes, the main motivation is basically being able to do your own research the best you can, at least I think for all the research code that is here, that is the main motivation.
Can you pass?
Theano was also made with the goal to help the research. We wanted to try much more different variation of models, and we found that it was hard to implement all of them, not to implement all of them at a high level, but to implement all of them at a high level with efficient execution. So the goal of Theano is mostly to try to optimize as much optimization as it can. And that is for the support for the research that use a numerical computation, more in particular what we do in our lab machine learning. As a research lab at a university, what brings money is mostly grants and the research itself and not the software. So that's what we back up. And Pylon 2, it's the same.
I think it's very important to talk about reproducibility when we talk about goals, and also think that all these projects fall in certain clusters. So one cluster is, say, probabilistic programming languages. So what would be great, I think, to have is would be some kind of system where you define some standard tasks or problems that are well suited for a certain class of tools or algorithms, and then all these, like code from Stan, code from PyMC based on Theano, code from Anglian or whatever, tries to solve this particular probabilistic model, say, and then you get some notion of how the results compare in terms of time, in terms of speed, and in terms of accuracy. And you can do the same thing for black box based machine learning toolboxes. So you could have some kind of framework where you define, okay, here's a data set, here's a task on that data set. Now these projects can upload their scripts to solve this task, and then there's some neutral comparison. I think this would be actually super nice to have to compare goals.
Bob?
Agree.
Yeah, our project, at least from my perspective, was not started for research. It was started for actually solving practical statistics problems. So what we really wanted to do was expand the scope of models that could be specified by users and solved. So it wasn't so much that we had a particular research algorithm that we wanted to test. It went the other way around. We started with the problems we wanted to solve, started building it, and realized that certain things wouldn't work, and that led to research. So the research is kind of a spin-off of the project. I think the main thing that keeps people going is that if you work on a well-organized project that has decent infrastructure, everyone can put in something and you get out more than the sum of the parts, or at least something where there's not too much loss on the contribution. So I think a lot of our developers are coming in because developing in Stan is easier than developing stuff from scratch.
I don't have anything to add.
Okay, so basically all kinds of goals exist. So now we go to the collaborating part. So these are open projects. So I'm pretty sure that anybody is willing to borrow a piece of code that works well if it's good. So let's look another aspect. In an open project, you have the code and you have the community. And the real tough question is, are you willing to share communities? Meaning to promote another toolkit within your own community? Which is the real litmus test for the collaboration. So let's do the same model. Chijin.
Well, I think if the goal is to help users, whatever the best for users, we will do. I think that's just the answer.
Okay. So then John?
I think the answer is yes.
Okay.
So in general, there's a lot of stuff around the core algorithms, and to the degree to which we can amortize all that stuff across a bunch of different projects by having a shared community, I think that's fantastic.
Why?
Yeah, I mean, I also completely agree, and we sort of do this by like wrapping up a bunch of stuff like libsvm, liblinear. I think there's a port of Webit in Lua. We can call Tiano stuff. So yes, like if we can share users, if we can share anything, then we should. I mean, because none of the projects is a big commercial undertaking, right? It's basically like people volunteering their own time, and then like hoping that there is going to be some advantage to doing this. So of course, if there's anything to share, we should.
Yeah, it's the same. I think everybody agree on that. I can tell more that in the case of Torch and Tiano, that is in the same field of deep learning, we have case where we collaborated on the same project, and part of the big project was in Torch, part was in Tiano, depending of the state of the project at that time. And I know people in both community that use both softwares, so there's a communication between different members. I think the core developers stay on their side, but the user switch more frequently between those two different software.
Heiko?
Yeah. So also absolutely yes, and I think there are two sides of this thing. So one side is you integrate other projects' codes into your own one. So in Shogun we have lots of libsvm, liblinear stuff, and we have actually lots of people are using your toolbox through Shogun, which I think is great. And there's also the other side where you as a project, if you're general enough, you try to, and I think this is actually not happening that much, that projects actually make an effort to make it easy so that their own tools are easily usable from other projects. So this is maybe something that there could be some more collaboration on, like talking about, okay, what would we need in order to use the cool stuff you've done in our project, and vice versa.
Bob?
I guess I'm a bit of a pessimist in this regard, and I'm not going to say yes right away. It's very difficult. We have a difficult enough time integrating software from our own contributors and our own projects. when you need to go try to take in another library, it's very, very difficult. We're using the Eigenmatrix library. We're certainly using everything in Boost, all the templating, all the parsers, things like that from Boost that we can. But I'm not sure what else we could use from other projects, like how easy it would be to pull little bits of projects out and implement them. So, thinking of like all the things we're working on going forward, we run into either licensing problems, like we might have used Doug Bates' stuff for MML, but it's all GPL'd, it's all tied up with the R libraries. So finding things that are actually modular enough to use, we certainly would if we could find them. But at the level of things like random number generators, we can do that. At the level of like, could we incorporate VW's updates, right, in our model? I'm not sure how that would actually work. The algorithms we can definitely share and re-implement, but sharing at the code level, if you're not doing something like wrapping up a bunch of components, is actually very difficult. Now, having said that, I always recommend people to go use whatever the right tool is. So I'm perfectly happy and have publicly recommended that people go use VW or an SVM library or something if that's what they want to do, and our software won't do it. So I think most of us are pretty happy with that. I think the people who actually build these projects tend to be less true believers than people with a little less experience. Because
I just wanted to add that aside from just wanting to share, there's also kind of an issue of exactly how to governance, right? So how is the check-in process controlled? And I think that's pretty non-trivial, actually, to settle amongst existing projects. When you're just joining a project, then you just go with whatever that current project does. But if you're trying to join to existing projects, that's a question.
Yeah, so I guess following up on what Bob said, I mean, I think, so I guess probably of anyone here, maybe I have the least ownership over any of these, so I don't really care about sharing communities. And in fact, some of my students use VW for stuff, some of them use LibLinear for stuff. It's sort of a matter of taste. But like one thing that definitely struck me during Bob's presentation is that I think that there is space to sort of take models that are declaratively specified as probabilistic models and try to solve them using sort of an underlying prediction framework rather than probabilistic inference. And I think this is sort of an obvious place where, I think code and communities potentially could be shared, and probably other people have other ideas. But.
More comments? Yes?
As some other people told, sharing code at the low level, the implementation. Right now, there's the benchmark that Koray showed in the presentation on the convolution. I think it's a level where it is easier in theory to have collaboration, but right now there's many technical difficulties that make it much more harder. That's why one of the goals of libgpurary, if we share the same base object, we can reuse much more code, because we don't need to translate between one object and the other object. There's also another part is, if we plan to make the code to be reused by other system, most of the time it will ask us a little bit more time as a first developer, and we don't always know if someone will want to use it. So maybe it's too much to ask to the original developer to plan right ahead to do it. But I think something can be done. It's the second user that comes, that goes see the project, see the code, refactor it a little bit to ease the implementation, and if the original author agree to accept those type of modification that don't bring new software but just ease the reusing, it will help the third and fourth and the other people, and it will also help those two users, because if there is an update to the code, they will be able to share the new updates. One way to share the code is with a common object, like libgpurary, but it's not always easy to move from the current object we have. Something else that can be done, it's just like BLAST, where you have a pretty drab interface with pointer, shape, and dimension and information like that. So if you move all the code into such an interface, that make it very reusable with other systems. So I think it's two different ways to ease the collaboration on the code.
So somehow the consensus that the sharing is good, but it's easier to share low-level things than high-level things. And well, questions? Yeah, Dan?
I'm not sure it's completely on topic, but in addition to sharing code, what about having a uniform place to share how different versions of code work on particular data sets, right? So if I'm somebody who's trying to choose a machine learning package and I have a problem that a machine learning problem that I want to solve, it might be nice to see, well, on this set of problems, which are similar to my problem, this package performs like this, and this package performs like this, and this package performs like this. Is there something like that?
Yeah, but there's MLComp, which is an example of that. Maybe some others.
Well, I mean, so this is one slide that I showed. We have actually a benchmark place where we benchmark the on convolutional nets. We benchmark the Kurzewski, Piano, Café, and Torch, of course.
So anyway, since we agree that we all want to collaborate, we're now going to break out in separate sessions.
Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.